Hi everyone, welcome back to my AP Calculus class. Today I keep explaining about the Riemann Sum, MRAM, midpoint rectangular approximation method. I'm still using 3 steps. First step is 4 rectangles. Second step is n rectangles. The last step is find infinite many rectangles to find what? Area under the curve with the x-axis. I'm going to use the same function y equals x cubed plus 1. The graph looks like this. X-axis and y-axis. And graph is parabola. Y-intercept is 1. I'm going to find that under the curve area from x equals 0 to x equals 1 of fx equals x squared plus 1. Step 1. Step 1. Find 4 rectangles area using midpoint. This M means what? Midpoint. So at first I want to make 4 sub-intervals from 0 to 1. So half is 2 over 4. And then quarter is 1 over 4. And 3/4, 3 over 4. 0 means 0 over 4. 1 means 4 over 4. And then I'm going to make 4 sub-intervals. First one is 0 to 1/4. Second one is 1/4 to 2/4. And then 2/4 to 3/4. 3/4 to 4/4. And then I'm going to use midpoint of each sub-interval. First intervals, midpoint. What is midpoint of 0 over 4 to 1 over 4? That is 1 over 8. How can you find that? Add those to end point and divide by 2. Second interval's midpoint is what? 3 over 8. Then next one is 5 over 8 and 7 over 8. At that midpoint on the graph, just draw rectangles. The midpoint of rectangles like this. So what is first rectangle's area? Rectangle's area is length times width. The length is always 1 over 4 because I divide 1 by 4. I made 4 sub-intervals, right? That's why length of one sub-interval is 1 over 4. Times, what is the height of first rectangle? First rectangle's height is y value and x equals 1 over 8. So plug in 1 over 8 for x of that given function equation, which is 1 over 8 squared plus 1. Second rectangle's area, same length, 1 over 4 times. The height is going to be y value and x equals 3 over 8 over here. Then the rectangle looks like this. That y value is 3 over 8, whole thing squared, plus 1. What is the third one? 1 over 4 times, okay, y value at x equals 5 over 3. The rectangle looks like this. That height is y value. Plug in 5 over 8 for x. Square plus 1. Last rectangle's area is 1/4 times 7 over 8. Square plus 1. I will find this sum of all 4 rectangles area now. All right, what is the common factor of each term? 1 over 4. 1 over 4 times 1 square over a square. I circle this part. 1 over a square, 3 over a square, 5 over a square, 7 over a square. I gathered those things all together. So 1 squared plus 3 squared, 5 squared, 7 squared, all over 8 squares. How many ones over there? 1, 2, 3, 4 ones. That means a plus 4. Okay? And then 1 over 4 times a squared is 64. And then 1 squared plus 3 squared plus 5 squared plus 7 squared. I quickly use my calculator. 1 plus 9 plus 25 plus 49 is 84. That's my calculator says that's 84. So 84 plus 4. I'm going to distribute properly. 1/4 times 84 over 64. 4 times 1. 4 times 21. So 21 over 64 plus 1 over 4 times 4 is 1. Okay, so I calculate what is 21 over 64. 21 divided by 64 is equal to 0.32. So 1.328. This is a little less than actual value. That means it's underestimated. Why underestimated? Compare this part to this part. The green part is just a little bigger than black part because that graph is increasing faster. So second half graph increasing faster than first half graph. That's why the green part a little bigger than that black part. So the black part a little smaller than green part. That's why the rectangular area a little smaller than actual area. So this value should be underestimated just a little bit. Okay. Anyway, I found that for rectangles area using MRAM. Step 1 is done. Let's go to step 2, which is n rectangles area now. Okay, let's go. Step 2. N rectangles area. So I'm going to use the same pattern that for rectangles area was 1 over 4, but this is 1 over n because there are n rectangles. 1 over n times there was 1 square plus 3 square plus 5 square plus 7 square if n is 4. But there is n rectangles, so it keeps going to 2n minus 1 squared. There was 7 square, right? 7 is 2 times 4 minus 1. So 2 times number of rectangles for minus 1. That's why last one is 2n minus 1 if we have n rectangles. And then the bottom was 8 squared, right? That is 2n squared. Because 2 times 4 is 8, that's why. And then plus n. Okay? If you're a little confused, you go back to step 1 and then comparing the 4 rectangles area and then find some pattern and then just compare to this, okay? I'm going to calculate this, simplify this. 1 over n times, okay, 2n squared, the denominator. So 2n times 2n, 4n squared. And I'm going to use sigma notation for the numerator. I'm going to use this part, sigma notation, sigma k equals 1 to n 2k minus 1 whole things square. Does that make sense? You plug in 1 for k into 2k minus 1, that result is 1 square. If k is 2, 3 square. K is 3, 5 square. If k is n, 2 minus n square. Sigma means summation, so add all those things, right? And then plus n. Okay, now I use distributive property by 1 over n. So 1 over n times first term, that is equal to 4n cubed. And then sigma k equals 1 to n. I want to expand that. 2k minus 1 squared is what? 4k squared minus 4k plus 1. And then 1 over n times n equals 1. Okay, 1 over 4n cubed, and then I use sigma notation, sigma formula, sigma 4k squared, right? For this coefficient came to the front. Sigma k squared, what was the formula? N times n plus 1 times 2n plus 1 over 6. I gave you this formula for the LRAM video. To go back that video, find that LRAM Riemann sum. I gave this for sigma formulas in that video. Check, okay? And the next one is negative 4 is coefficient. And then sigma k. Sigma k formula was what? n plus 1 over 2. What was any numbers? Sigma c, there was cn. So 1 times n, just n. Whole things plus 1. And then distributive property by 1 over 4n cubed. 4 and 4 cross out. So 6n cubed over nn plus 1, 2n plus 1. And then the 4 and 4 cross out. So negative 2n squared over n plus 1. And nn n cancel out. And the last part, so nn n cancel out. So 1 over 4n squared plus 1. I'm not going to do any more. You can just simplify more, okay, simpler forms, but it is enough. Anyway, I found n rectangles area. Our goal is not find this answer. Our goal is step 3. I'm going to use the limit n approaches infinity of this whole things to find that actual area under the curve with the x-axis. Okay, because the second term and third term, there's infinity over infinity form over number of infinity form. Because the denominator is bigger than numerator, the limit value is going to be 0. That's why I'm not going to do more simplifying. Okay, let me keep doing step 3. Step 3, just find an infinite number of rectangles. Using limit concept, I'm going to put limit n approaches infinity of those whole things. First part, n plus 1, 2n plus 1 over 6n cubed. Second part, n plus 1 over 2n squared. The third part, 1 over 4n squared. 1 is just 1. Limit n approaches infinity of 1 is 1, right? These two parts 0. And the first part only, right? It is, if we expand the numerator part, that will be 2n cubed plus something, blah, 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 blah. It doesn't matter because they have same degrees. Third degree. In that case, okay, I told you many times, leading coefficient of numerator and denominator, that is going to be your answer, which is 2 over 6 in this case. So what's the final answer? 2 over 6 means 1/3. And then plus 1. So 4 over 3. So we always find same answer 4 over 3 in LRAM and RRAM. Now today we use MRAM. That area should be same area because I use the same function. I explained the 3 steps of MRAM with the same function today. In the next video, I try to explain TAM, which means trapezoidal approximation method. I think this is the hardest one. Okay, anyway, thank you so much for watching my video. Then please click subscribe and like and turn on the notification. Thank you again. See you. Bye-bye.